A pre-stressed concrete beam of section 120 mm wide by 300 mm deep is used over an effective span of 6 meter to support a UDL of 4 kN per meter, which is exclusive of self-weight. The beam is pre-stressed by a straight cable carrying a force of 180 kN, is located at an eccentricity of 50 mm. Determine the location of thrust line in the beam and plot disposition at quarter and central span section. So by looking into the data, first we shall try to draw the sketch. The first part always in the pre-stressed concrete is to draw the sketch carefully. So this is the cross section of the beam. It is given as 120 by 300 mm and eccentricity is directly given. This is the cable. So this is the cable point. It is directly given as E is equal to 50 mm. And next let us draw the longitudinal section. So this is the longitudinal section. Span is 6 meter and UDL value is given as 4 kilonewton. Next, this represents the pre-stressing force P on both the sides. Next. So after drawing the sketch, we need to carefully compute what is the dead load, that is self-weight. Area into density 120 by 300 mm into 24. We get it as 0.864 and finally add up both the loads, dead load as well as live load. We get it as 4.864. So for this total load, we need to compute the moment at the support quarter span as well as the central span as per the statement of the problem. So next, after finding out the total load, it is very much necessary to find out, draw the simply supported beam. Let us draw one simply supported beam with UDL. Since it is a quarter span means 6 divided by 4, quarter means 4. It comes out to be 1.5 meter. Therefore, we have considered a section at 1.5 meter. Okay, and again central span means 6 divided by 2. Center means half. For that, one more section is been considered like this. After considering the sections, we need to find out what is called as moments. We know that for a simply supported beam, bending moment is at this support is 0. This is very important condition. Whenever we come across the simply supported beam or whenever there is hinge support or the roller support, knife edge support, the moment value is always 0. And at a quarter span, we need to apply the equilibrium conditions and then we need to find out what is the bending moment at a quarter span. So we know that the reactions at both the ends is 14.60. So since this is at the quarter span, VA into 1.5. VA is 14.6 into 1.5. So here this actions, it is negative minus 4.864 into 1.5 into 1.5 by 2. We get it as 16.43. And lastly, at the central span, that is at the mid span, we have the direct expression for the central span, that is WL square by 8. So substitute everything, we get the answer as 21.90. And next part of the problem is determining the location of the pressure line. So the pressure line can be calculated in the case of the straight cable as mentioned in the as showcased or as was shown in the expression. The pressure line or the location of the pressure line is simply calculated as E bar is equal to M by P, where M is the bending moment, P is nothing but the pre-stressing force. So let us apply this equations at different locations. That is, let us apply it at first support. Since the bending moment at the support is 0, since the bending moment at the support is 0, this is 0. And next we shall calculate it for quarter span. So for the quarter span, the bending moment what we have calculated in the previous step, it is obtained as 16.43 and pre-stressing force is common for all the case. After substitution, we get it as 91.3 and finally at the mid span, M value obtained as 21.9 divided by P, we get this value. And next it is necessary to plot the pressure line. So while plotting the pressure line, before starting the pressure line, we need to first complete the drawing of the longitudinal section. So let us draw the longitudinal section of the beam. So this is the longitudinal section, and this represents the pre-stressing cable. This is P. So from the pre-stressing cable, we need to measure that E bar value for the given location. See, at this support it is 0. At this support it is 0. So you can notice that here this is the support with respect to the cable position. Here bending moment is 0. Since bending moment is 0, your pressure line value also it is 0. And next we shall again plot it for the quarter span distance. What is the quarter span? Total length is 6 meter. From here to here it is 6 meter. Out of 6 quarter means 1.5. So measure 1.5 distance from here to here, and then from here to here measure it vertically for a distance of 9.13, and come to the central span. Again central span means 6 divided by 2, that is 3 meter. That is totally it is 3 meter. Again measure 121.7 from the central, at the central axis or the central point, and similarly again the last position is the quarter span, and from there again you measure 91.3. So after measuring we need to connect everything with a dotted line, which is the most common method of representing the pressure line. So I am going to connect everything with respect to the cable position, and this represents the pressure line. This is how we normally generate, or normally we plot the pressure line, and this it is exclusively for the straight cable.